Hey guys, welcome back to AlgoYogi. We are doing graph series, and before we move on to our next problem in the graph series, I really wanted to quickly go through union and find operation, which is also known as disjoint set union, DSU, or just union find. This is the operation that it consists of two main operation, which is union and find. So union is basically you're bringing these two sets together, or two node or elements together, and basically you're grouping them into one, so that now they both have same parent, and or they both report to the same node. So you're grouping them together, and then find operation basically gives you the root element or the parent node of two elements. If you give it two nodes, then it will give you the parent element of both those nodes. This operation is really useful in finding the cycle detection, and there is a really famous problem. It's called merge accounts. That would be the next problem we will be solving in our graph series. And before I wanted to actually dive deep into that problem, I really wanted to cover this before, so that we are like equipped enough with the basics of union and find, and have our template, code template ready, which we will be writing right here. So let's get into disjoint set union. So what is it about actually? I've already said it consists of two main operations, union and find. What are those operations? So for example, let's consider we have 5 different sets or 5 different elements. What are those elements? Let's create those 5 elements, and I'll say these elements are, so 1, 2, 3, 4, and 5. These are the elements that I have right now. Now what I'll do is right now all these elements, they have the parent of these. They're right now all distinct elements. They do not have anything in common. Like they are independent set or element in themselves. And what I'm trying to say with that is, like, they do not have any parent, any root parent that they report to. So this is a separate element in itself, or set in itself. 2 is also, and 3, 4, and 5. So if I want to ask them what is your parent, in theory, what is your parent, so they will tell me that I am my own parent, or I am my own leader. So we will have an arrow pointing of these elements or sets to themselves, because they right now report to themselves. But what if I tell you, what if my problem solving requires that I find some similarity in these sets, and I want to group them together. So I want to introduce union. So I want to introduce union. So in union, what I want to do is, my union will take basically two elements, A and B, and then what it's going to do is choose one of them as parent. Although right now A has itself, it's reporting to itself, so it's parent of itself. B is a parent of itself. So what we'll do is, first we'll find what are your root parents. So I'll say that parent, or you can say root A would be, we will find it out by the find operation, and B will be found out by the find operation. What is find operation? We will just write it, but before that, let's complete it. If these are not same, if root A is not equals to, is not equals to root B. So what I'll do is, I'll choose I'll choose maybe A. I'll choose A as maybe the parent root. So this root. So and I will mark that parent of B would be root A, and that is the entire job of my union. Okay. How about find? So let's write union let union be right here, and then let's write find. Well, find will be taking just one element, and then what find will be doing is asking if A is not parent of itself, if A is not equals to parent of A, then it will return find parent of A. So what this is saying is it will be pointing to some element, and then it will return us the parent of A's parent's parent. So what this means is, let's say I union 1 and 2, and this will give me basically, because they do not have any common parent, so we'll make 1 as common parent, and now 2's parent would be 1. And if now I say find 2 or find 1, they both should be returning me 1. Why? Because I have now union 1 and 2, and now they're both pointing as root node or parent node as 1, because 1 itself is its parent, but now because we just unioned 1 and 2, now 2's parent we have chosen 1 as its parent also. So that is the entire code. Although right now it seems super simple, but like when it comes to its utility, you have to like have a good understanding of how and where you are going to basically use it in your code, because while solving some problem, this will be a small set of the code. It will be like this utility function that you will be using as part of the, solving the main problem, which might require like even some other workaround. You will realize that like when you solve this accounts merge problem, then you will realize it. So right now you have this right here, and I'm going to write the code for us. So let's just write a class. We'll have a class called union find, or you can call it joint set. So union find. So let's create the init function. That's the initializer function. We'll take self, and then we can give it the size of our these individual sets that we are creating. So we can call it n. We will provide it when we call the class union find. So right now this will be a list. So we'll say that we can call it parent list, and it will be a list in itself of size n. All right. Now, because it's pointing right now, like you're providing it the number n, that means it has created a list from 0 to n minus 1. Now, at each index, that particular index will have the value as its parent. So right now, if you want to, you can fill it up, but there is no need, because we will be writing these. Let's say first would be we can write find, because find is the easiest to write. So we'll have self x. Find is easy. So you'll basically be asking if self dot parent of let's say you're saying x. Sorry, because this x is an index. or you can say node, if parent of x is not itself, it's not equals to x, then what do you want to say? Now if let's say there is a tree, but usually in the beginning, if you're creating these disjoint sets or disjoint nodes, right now their parents is itself, and I'm trying to find that out. But if you have performed some unions that we have just realized right here, you can see while I did union of 1 and 2, now 2's parent is also 1 and 1's parent is also 1. That's where basically you will not find that x is pointing its parent to itself. So what you'll do is you're gonna call this value would be different, this value self dot parent of x would be different. So you can call and I'm sorry, why this should have been better. Yeah, my bad, I'm sorry, I don't know why I wrote self there, because I was too scared to not write self, and I just wrote in place of def as self. Okay, so if that's not the case, then you will return, we can say self, I think self dot find, we can say self dot find. There will be too many self because we are writing this class self dot parent of x. Otherwise you can just simply return parent of x or x itself, I guess. I don't know, it will be the same because it will be pointing to the same value, parent of x. All right, now our next function would be union. So union, let's have union will be taking basically this time two values a and b, because we are trying to union these two different sets or different elements, node, whatever you guys want to call it. So let's find out the root a or parent a of this node first, and we'll send in a to it. Then we'll do the same thing for the b, because we are trying to know if are they really part of the same set. If they are, then we don't need to do anything. If they are not, then only we will basically choose one of them as parent and then assign another one's parent to one of the nodes. Usually it's going to be a, because we want to have some convention, I guess I would say. So root b would be, if you will find it out from finding it using it, the self dot find b. Now if these root a is not equals to, so I'll say if root a is not equals to root b, if these are not the same value, so now we're gonna assign parent of b, which is root b, if they are different set. Although just remember, these two could be part of two different sets, not just like two elements. They could be part of these two different sets. There might be multiple elements, and there might be definitely there have to be, if they are already like union together, there have to be one common root parent, root node. So that root node, I will choose that second root node's parent to be the first node's root parent. It's tricky, but I hope it's making sense. So I will choose that as basically the parent of b's root. Okay, and then I can basically return. Do I have to return anything from here? I don't have to return anything. I'll just, like, if they were not same, then I will assign and then I come out. Let's try it. Let's basically have created, let's call union find, and let's call union find, and I'm creating like a set of 5 nodes, so from 0 to 4. Now let's join basically two different nodes, have them point to the same parent, or union them together. So I'll say union find dot I would say union, because that's the method, and I'll provide it 0 and 1. I'll say 0 and 1, and then once that's done, what you want to do is you want to now I want to find out if they both have same parent, because that will confirm it, because I have just unioned them together. So I'll just print. What am I printing? I'm gonna say union find. If union finds union find dot find of 1, and then I'm gonna say union find of 0, or I can put 0 before. So what do you think these two should be giving me right now? Because now I have chosen to union 0 and 1, they both should be pointing to the same parent, right? Which should be 0, because that's how we have written. Like it's gonna first value is A, second value is B. If they don't have common parent, then we are basically putting it in our same pointing them both parent to the same node. So let's try it, and I hope it's gonna be 0 0. As you can see right here, it is 0 0, right? Then what we can do is now we have unioned 0 and 1, so I can show you guys right here. Let's say right now I'm gonna change these values to what we have just. So I'll say right here, and I'm gonna create one more 0, because that's how we have chosen, because the index starts at 0, although we have created 5 elements. Now what I'll do is right now you can see the 0 is the parent of 1, right? Parent of 1. Now I have 2, then I have 3, and then I have 4. Okay, let's do one thing. Let's join 2 and 3. Let's join 2 and 3. 2 and 3. I'm joining 2 and 3. So what do I want to do now? I have joined 2 and 3, so that means behind, like in our algorithm, we must have moved 3 under 2, because that's how it works. It takes the first element as A and then second element as B. So what it must have done is, like, now 2 is A's parent. Now if I join 0 and 2, if I join 0 and 2, so right now you can see that these two have same parent, and rather than printing them in the different line, I can print it in the same line, right? So what I'm trying to show you guys is, right now if I have joined 2 and 3, they both point their parent, basically the root node of 2 and 3 should be same, which should be 2. So 0 0 2 2. You can see right now. Now here's the magic. What if I join union? What if I union 0 and 2? What if I try to union these two? If I'm gonna union these two, that means I'm trying to move this entire thing point to basically 0, because 2 will be pointing. So if you see logically, this 2 will be pointing its parent to 0, and this 3 is pointing to, but 3 is kind of also pointing to the root parent 0, because 0 is a parent of itself, but 3's parent is also 0. So let's union. This is the magic here. So if I union if I union 0 and 2, 0 and 2, and if I try to find the parent of, let's say, 3, if I try to find the parent of 3, so I'm trying to find the root of 3, what do you think that should be? I think that would be 0. Let's find it out. Let's run it. Exactly. So now you see how we have just connected. Only one of the node is like independent right now, disconnected. There are 2 sets now. There are 2 sets, and in together you can call them like this is basically a disjoint set. But you could union them. You could choose to basically union 3 and 4, but at the end you will realize if 4 is parent to 3, then 4's parent will also be 0. So I can union 3, I can union 3 and 4, and if I try to print the parent of 4, that would be also 0. That would also be 0. That's it. This was all about union and find. I hope you liked the video. This was really simple, and I think I might make one more video of this union and find with the ranks, etc., because you don't want to make a tree that is like really long. We want to have a splitted, basically equally splitted or like balanced tree that is pointing to the one common root, or the way you union, the way you find, that should happen in constant time. That's what we want to achieve. So I think we will study about rank and all, but I think we are equipped enough to now like jump into these problems which actually need basically the utility of union and find. So if I switch my view here, let's just not. I'll see you guys later when I will move to the next problem, and that will use union and find. So see you guys later in the next video.